Demux Techie. So in this video we discuss about this demultiplexer. So demultiplexer is nothing but it is also a combinational circuit. So in multiplexer what you are seeing, so there is a multiple inputs and there is a single output, so one output. Whereas in Demux it is like quite different to the mux. So it is quite opposite. So how only one input and multiple outputs. So what here you observe in the Demux, so there is a single input in the mux and the one output. So in Demux only one input and multiple outputs. So here in this video we discuss about the 1/2 Demux. So there is a one input and two outputs. So for 2 power 1 is nothing but 2. What is this one represents the select lines. So here only one select line. So it is our truth table. So what is the if the select line is equal to 0, so the d value is going to assign to y1 and y2 is going to be 0. If the select line is equal to 1, so the d value is going to assign to y2 and y1 becomes to 0. So observe the truth table here. So if the select line is equal to 0, so d is going to assign to y1. So what is the value of y2 is going to assign to 0. So if the select line is equal to 1, so data will going to assign to y2 and y1 is going to be 0. So by using this truth table you are going to write a Verilog code. So the Verilog code is here. So it starts with module and end with end module. So it is our module name. So what are the inputs here? So I means here data here d is said to be I in this code. I written like I, and the only one select line is and output port. What are the output ports? So there are the two output ports. In vector representation I represent like that, 1 down to 0. So means O of 1, O of 0. So like this. So they are the 2 bits. So reg. So there is a always block. Inside always block we are going to assign this O variable. So that's why we make output port as reg data type. So always at the rate it is our sensitivity list. So inside the sensitivity list we represent with star means. So if any change in one of the input, it is going to be executed. So this is the meaning of the star. If you want only the particular change in I, so whenever there is a change in I, then only my output is going to be executed. Then we can simply write I. So if the I is going to 0 to 1, then only it is going to execute. Otherwise if I is going to 1 to 0, then when there is a change in the input from one combination to another combination, then only it is going to execute. So if you write S means, so I is changed or not, doesn't matter. If select line is changed, then only it is going to execute. If you write star means both I and S. So both I and S are, if any change in one of them I and S, so it is going to execute. That is about the star. So you can start with begin. There is a multiple statements. This is how you use begin keyword here. So it case. So what you know about the case statement. So what are the variable you write in the case? So that condition is going, if the select line is equal to 1, so it check the condition, what is the variable here, so you can assign the value. If it is equal to this particular value, then the particular statements inside that will be going to execute, otherwise this is going to be executed. So if the S variable is going to be 0, then this what are the lines inside this will going to execute. So what are the values here? So here you can see if the select line is equal to 0, the data will going to assign it to y1. y1 is nothing but O of 0, y2 is nothing but O of 1. So O of 1 is equal to I. So data is going to assign it to y1. So remaining bit is going to assign it to 0. See if the select line is equal to 1. So O of 0 is going to 0. So here you can see the select line is equal to 1. O of 0 is be 0. Then remaining O of 1 is going to be equal to the input. So here you can see same we can written here in the code. So and case will end with end case, and this begin, what is the begin here, so it will be end keyword, and there is a module is end with end module. So it is our test bench code. So you all know about that module is module start with module and end with end module. So followed by module name here, this module is followed by module name, and what are the inputs are should be in reg data type, outputs are in the byte data type. So why you are particularly using reg means, here we design every time we discuss about that. So when are going to initial block or always block, so when are these two blocks are going to be executed, so what are the variables we are used in these blocks, so it must should be reg data type. So that's why only we represent I and S are the reg data type. So inside the so there is a Demux 1/2. So it is our design code module name. So to instance here, so you can create the connection between the test bench code and design code. So that's why you can instance the design code here by follow the design code module name and followed by instance name. So no need to mention the same instance, means particularly only single. There is no rule to mention the particular name like that. You can use any name. So mostly we prefer DUT in Verilog. So inside it is our port list. So here I connect the ports by order. So initial begin. In the initial block we are going to give the different combinations for input, and /5 is our delay for giving some combination, and you can give delay. And again you can give some input combination, then again you give delay. When you are going to stop the simulation, then you simply write the finish keyword, then you can stop the simulation. So finish keyword is for the stop the simulation. So begin is end with end, and these 4 lines are used to generate the waveform in EDA playground. I already say that. So if you want to generate the waveform and you want to know your functionality is correct or not by verifying according to our waveform, then you can use these 4 lines, otherwise no need to write. So it followed by end module to stop the code. So it is our final output waveform. So if you can see that this is our input and it is our select line. If the select line is equal to 0, so input is going to assign it to the O of 0. Then O of 1 is going to be 1. So you all know about here you can observe if the select line is equal to 2. Sorry, select line is equal to 1. So here you can see select line is equal to 1. So what does the select line is equal to 1 means? So input is going to assign it to the O of 1 and 0 is to be O of 0. So it is like O of 0 and it is like order like this. So here O of 0 is equal to 0 and O of 1 is going to be I. What is the I value here? It is a 1. So 1. So it means 2. So that's why our output will be 2. So like that you can cross check whether your functionality is correct or not by using this waveform. So it is about code for the 1/2 Demux. If you have any doubts until now, any particular thing, you have to comment it, and thanks for watching. Until then, bye.